Nearly done, guys. Yay! Alright, so what's left for me to cover now is basically just to give you a rough breakdown of the standard things that you need to know for each topic. I'll also talk briefly about what you might want to know to be able to secure your band E4, and pretty much it's just going to be a summary-based lecture at this point. Alright, so let's do it. So with integration, you should probably by now know all of your standard methods: substitution, by parts, trig integrals, use identities if you need them, partial fractions, and reduction formula. You should be very comfortable dealing with most of these almost all of the time. Usually there's nothing really hard in integration, only one I know is a 2014 question really. And quick remark on reduction formula, almost always you will need integration by parts. As far as I know, the only time that you don't need integration by parts is when you're integrating tan to the n theta, or you can make it into tan to the n theta by use substitution. They are the only times I know where you can basically just get out and do it using shear algebra. Complex numbers, normal things like, just adding, subtracting, multiplying, dividing, converting to mod arc form, those are nice and easy warm-up questions for you. The standard method that you might want to know is basically dealing with square roots, dealing with nth roots, so like their cube is equal to, like say, I don't know, 1 plus I. You can also get to prove trigonometric identities, like cos cube theta, or every now and then maybe cos 3 theta. You might also be given something along the lines of, exact values every now and then. And also some very simple lockers like mod z is equal to 1, arc z is equal to pi on 4. You should be very comfortable with that as well. And pretty much that's also some formula you need to know, and in particular, I guess, the Moivre theorem. Polynomials is very strongly tied to complex numbers. It's really just polynomials in 3 unit plus complex numbers combined to each together. So not really too much for me to say. You saw in the 2015 question, that's one possibility of advanced E4 polynomials questions. A more advanced technique basically might be dealing with your roots and coefficients of polynomial. You might be expected to be able to manipulate the roots and coefficients that you're given. Your roots might form a pattern, a GP or an AP, for example, or there might be reciprocals, blah blah blah. And you also need to probably know quite a fair few theorems about the roots. So my example here is basically, well, excuse me. If you have a complex polynomial and all the coefficients are real, then conjugate, that's a weird spelling here. If you're given a complex root, then it comes with conjugate pair, that's all fair enough. And there's more to it, but basically that's the rough idea. I cover most of these in my notes anyway, so it's okay. Graph intuition may help. If you ask me, it can help a lot if you actually anticipate what a graph does by just being able to look at the equation. You expect that, your x coordinates being modified or your y coordinates being modified instead. You also want to be able to handle simple things like add, subtract, multiply, divide, and take to some power, square it, cube it, or something like that. You need to be comfortable with implicit differentiation. That goes for conics as well. And most of the time, they're going to be giving you a graph and they're going to ask you to do stuff with it. They're usually not going to make you do something like, say, graph each of the sine x, each of the inverse sine x, or something like that. They'll give you the graph and they'll tell you to do stuff with it instead. Conics, the only real standard things is basically just my list here: eccentricity, tangents, normals, graphing it. And honestly, there's always going to be some stuff with Euclidean geometry, basically areas and stuff, coordinate geometry as well, midpoint, distance, gradient, blah blah blah. Honestly, it's really just messy algebra. It just makes me want to stab my eyes. Oh wait, crap, I have glasses, I can't do that. Never mind that. Volumes. Your 3 standard methods for your volumes are when you deal with slices, so those are your discs and your washers, your shells, and your parallel cross-sections. For these two, you might want to memorize the formula so you have a rough idea of what you're heading at. Cross-sections, they can be probably a bit more diverse. If you ask me, this is the only real topic that's basically black and white, and when I say that, I mean it's fairly predictable. Mechanics, always draw your vector diagrams. Even when you really think you know what's going on, draw your vector diagrams anyway. That's the easiest way to make sure that you've catered for every single force that you've been given. And also, you need to know how to resolve the forces anyway, and a diagram is an easy way of getting out of not showing working out, because the diagram is working out when it comes to mechanics, fortunately. Circle geometry formula, nice and easy. Your standard methods are basically, well, mechanics in a nutshell can be broken down into resistant motion. So when you do resistance in horizontal methods, up and down, you might want to get used to them. Also gravity that appears every now and then, a bit of a rare one, but it does happen. And circular motion, your two main applications are the conical pendulum and the bank track. You also want to be able to use these formulas for some very simple questions, but pretty much if you've done enough mechanics questions, you've basically seen the range of possibility that they can give you. What's harder for harder 3 units? Well, I don't know. I don't fucking know. What is standard for harder 3 unit? Nah, but like, the syllabus expects you to know these 3 things at the very least for harder 3 unit. Induction is a very common culprit. Circle geometry is also a very common culprit. And inequality proof is perhaps the one thing that appears pretty much every single year. Induction is pretty much your same old process. Just do n equals 1, n equals k, n equals k plus 1. Circle geometry, my best advice for you here is to be able to, in a way, see what the theorem actually looks like. So, for example, with the alternate segment theorem, I see a triangle and a tangent, and then I know what it looks like. Same with cyclic quadrilateral and all of that. You might be given more than one circle as well. If that happens, try focusing on one circle at a time. And also, don't forget parallel lines, similar triangles, all of that stuff in 2 unit. You never know when you need them. Inequality proofs, I'm pretty sure I've covered everything on that by now. Alright, so that's basically for your average typical marks. If you want to secure your E4, then these are the things that you might want to consider now. For integration, a really hard integration question will either be a very nasty reduction formula, or something that wants you to actually know your result of definite integrals. For example, integral of an odd function is 0. The f of x equals to fa minus x trick. That might, well, mispronounced it, but you should probably know that trick as well. You should also be good at handling your trick identities when you need it. You never know when they'll be necessary. And that's pretty much the easiest way you can excel at this topic. And if you're really good, something that you might want to consider doing is trying to solve integrals by just looking at them. So basically be the type of person that's at the integration B level. Complex numbers, we already seen the first one, that was a 2015 question. Vectors tend to be one of the big things that distinguish between E4 and E3, because a lot of E3 students still don't know how to do vectors, which is fair enough. It's taught very poorly. It's something you really want to be skilled at if that's the scenario. Locker's problem, for example, you want to find the maximum modulus or the minimum argument over some region. That might be a situation when this happens. Every now and then you might want to actually do a proof that starts off algebraic and then for some reason just chuck in the Argand diagram into it. If you know what you're doing, there is nothing wrong with that. You can absolutely do that, but it is just very dangerous. You've got to be careful what you're doing. Problem is, I've seen situations where it's absolutely necessary as well, so yeah. Oh, and roots of unity, you never know when that will appear. Roots of unity, know your 2 fundamental properties. Omega to the n is equal to 1, and the very long sum is equal to 0. Know how to prove it, and then everything else, just wing it. Not literally wing it, but yeah, you get the idea, hopefully. Polynomials, again, mostly complex numbers. The hardest thing you can see in polynomials basically when they knock in the binomial theorem with you, and you might need to equate coefficients, do substitutions, you don't really know what to expect, product of roots, blah 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 blah. It's too hard to just list off the top of my head. Pretty much, you just see a polynomials question, it's usually an easy topic. Very rarely will there be a question that really targets the band E4 that strongly. Graphs. Not so much for me to say, because graphs is literally just the same thing over and over again. If you know how to do graphs and you're just aiming for an E3, then pretty much there's not really much for me to say. The only thing that I might think is worth mentioning is, say, if you wanted to find the domain and range of sine inverse of each of the x, that might be something that's a bit more challenging, but that's pretty much the furthest of extent that I would know of. Conics, well, conics, you might be given, like, say, in a typical conics question, you'll probably have around 2 or 3 variables at once. You can be given up to about 7 of them, I think. So, like, A, B, X, Y, X0, X1, and something else, maybe, eccentricity, and you might want to be able to get really skilled at handling all of those at once as well. And, well, yeah, that can be really, really hard. What gets people at E4 in Conics basically the ability to be able to handle algebra and coordinate Euclidean geometry at the same time. You should be prepared to use substitutions, adding or subtracting or multiplying, dividing equations as well. And you never know when these appear. These are just some things that might appear out of nowhere and you just gotta live with it. This is a topic where you might be expecting 4 markers as well, to be honest. Volumes, yeah, like I said earlier, it's mostly parallel cross-sections that can be really, really hard. You need to be prepared to deal with cross-sections that are 1, on the number plane, and 2, not on the number plane as well. And you should always draw out your cross-section if you need it and exactly visualize what's going on. If you're really good at intuition, you might want to work backwards and see how your cross-section actually is derived to begin with. But usually you'll have to experiment. You might need to use, like, say, Pythagoras' theorem for a circle. You might need similar triangles or the weird thing that you did for the trapeziums. And pretty much those are the E4 techniques for volumes. Mechanics is just this list. Too many vectors, too many variables, nasty integration and algebra. And if you can handle all of that, basically you've got mechanics covered as well. Projectile motion and simple harmonic motion, well, I've only seen projectile appear once, and simple harmonic motion never. That's just there just in case, because some four-year students will forget about these two and just ignore it, but you never know whether or not they'll appear, and it has appeared before at least once, so just be prepared. Hardest 3 units. Basically, that is everything. Everything in hardest 3 unit is targeting band E4 unless it's the one little no-brainer just to make you feel a bit better. Well, it made me feel better, at least, when I was doing 4 unit, you know? And all I can really say about it is, don't just stare at a question and think, oh, this has to be how to do it, and this must be the way to do it. You can't say for sure unless, basically, you know you're on the right track, but you can't really say that for sure. Just count on it and hope that you pick the right approach and basically brave through it. And again, as a reminder, use 2 unit and 3 unit. As you'd expect, 4 markers and pretty much quite normal here. Okay, and perhaps before I finish the recording, this is basically the Casio FX100 AU Plus calculator that I advertised in my notes for complex numbers. If you bought one of these, I'll show you how it works just in case you never figured it out. So the idea is that you have your mode here, and number 2 will get you into the complex numbers mode. And what you can do now is, I can just type, like, say, any complex number, 1 plus shift E and G, which gives me an I, and surprise, surprise, there is my 1 plus I. And what I can do is I can add, subtract, multiply, divide with these things very easily. I can also put it in the absolute values. If I just type it into my absolute values here like so, I will actually get to square root of 2. So it's really, really fancy. And you can even go further. So you'll realize there's a C and P or X button here. And to get into it, you type Shift 2 and you open up this menu. And what you can do here is that you compute the argument of a complex number, you compute its conjugate, and you can also convert between the mod arc form and the Cartesian form. And that can save you a mark that's lost by silly mistake. So what I can do here is I can say 1 plus I, 1 plus I, and then I'll go into Shift 2, and I'll convert it into the mod arc form, which is this R angle theta here, and I will actually get given root 2 with angle pi on 4, as was expected, which is really nice. And so this is useful for 4 unit. For your 3 unit exam, you might want to consider, so I'm back in my normal mode now, you might want to consider how this STO button, well, can't find it, over here works. And what this does is that it allows you to store your numbers. So what you can do here is, I will type like anything, I'll just type 1 plus 2, which gives me 3. I'll get to 3, and then I'll type Shift store as one of these letters here, A, B, C, D, E, F. Suppose I pick C, and now I've basically stored that value in C. So what I can do here is I can re-access it by just typing alpha, C, in, and there's my 3. And that's basically how the memory keys on the calculator work. And that can be really helpful for 3-unit students, especially when there's a weird finance question coming up and just a lot of numbers to crunch. So here, there's some nice calculator tricks for you. And now we've made it to the end. Congratulations. And thank you for staying with me for so long, despite knowing that I have a very terrible list. Just a reminder for all of you to use whatever resources you have. Use the forum, ask your peers, ask your teachers. Whatever you have, use them all to your disposal, especially past papers. Ask us, ask me if you need to. And all I can say now is best of luck, and I know all of you will do well as long as you don't drink and drive. Get a drink and drive. Ba-dum. See ya.